Hey, how's it going, everyone? How's the food? I hope someone here also came for something more than food. I hope that your choice of staying in the office, even though it's quite nice outside, is not going to be a bad choice. So let's see about that. First, I want to thank the Productboard team for organizing this event. It takes quite a lot of effort to put everything together. Yeah, and also thanks some of the colleagues who provided me feedback on the presentation. Yeah, so why the clickbait topic, right? Why the clickbait title? Why did I call it all the buzzwords? Well, simply because I think that there's too many buzzwords flying around. There's too many new cool frameworks, you know, methodologies and architectures and everything. And I think it's just moving so fast, and it might be quite difficult to orient yourself in the technology landscape. And certainly I don't think that everything new is good for you, as you will hear. I might be a little bit controversial, so sorry about that. My opinion certainly does not represent the opinion of all product boarders. There certainly are some who will disagree with me. So take it more as like my personal retrospective on the last 8 years of Productboard. Yeah, let's go. A little bit about me. I've built various types of software in the last 15 years. I built desktop applications, mobile applications, you know, working with C#. But in the end, I stuck with web, where I also traveled the whole stack from infra all the way to front end. You know, I was the cool Linux admin guy that nobody sees at the beginning. But in the end, I turned out to be a staff engineer, which is my current role at Productboard. Before Productboard, I co-founded a startup called Avocode, or respectively, I co-founded the team that was behind Avocode, which got acquired 2 years ago. So congrats to my ex-colleagues. I'm a generalist, so I don't definitely, you know, focus on what are the latest ways of how to optimize the kernel in Linux, you know, and how to optimize the build time of new open source operating systems. I'm more focused actually on the business. I'm focused on solving real customer problems using software. So that's, I think, where I shine the most. As you can see on the graph, I started coding more again starting March this year. Before I was writing a lot of Notion docs, which, as some of you probably also do as maybe architects or senior engineers. A little bit of context. I see a lot of Productboard folks in the audience, also some ex-Productboard folks, so there's probably not going to be much new for them, but there's a lot of you who don't know much about Productboard, especially on the technical side. So I took some time and I put together a few scripts that extracted some interesting stats about our code base. So the blue line here you see is basically the count of packages that we have in our front-end repository, meaning external dependencies, excluding dev dependencies, basically graphed over time. The green one is the number of dependencies in our main monolith on the backend, Ruby on Rails monolith, also including only production ones. Then I graphed the number of engineers, which, you know, as if you read the news, you probably know that we laid off a few, but we're hiring again, so check the check the website. Yeah, I said it's going to be sarcastic, right? So yeah, a little bit of context, right? So even before the year 2015, there was a time of a few years that our CEO and CTO, Hubert and Daniel, spent a few years talking to customers And throughout the few years, they've actually built 13 prototypes. So even before we've actually started building the final version of the app, there were many other apps. They were like complete different stacks. So, you know, Daniel was basically trying out different front-end frameworks and back-end frameworks, you know, just trying to see what works, talking to customers, getting out the building. So at the beginning, the tech was definitely not the most important piece. Yeah. But as I said, at the end, we started building Productboard. That was the 14th prototype around the year 2015. We picked Ruby and Ruby on Rails respectively on the back end, because back in those times, there were not that many other choices in the startup ecosystem, maybe apart from Python, but it was on par back in the days. Yeah, and front-end was kind of at the beginning. I think it was some very, very earlier versions of React. And at the last minute, on the 14th prototype, Daniel decided to switch to React, which is something I'm very, very glad for. I think that kind of solved us a lot of things. Otherwise, we would probably be building a Angular or some Ember front-end app. I wouldn't want to be rewriting it today, as probably a lot of people do today. Yeah. So at the beginning, because we're like looking for validation with customers a lot, and the product that we are building is quite visual, we decided that we're going to put a lot of code on the front end. So we picked a heavy front end single page application architecture, right? So the split of the code was around like 80% of the code was on the front end, which is, you know, which might not be typical for every application. Also, the data fetching was quite opinionated, I would say. So basically, we just downloaded all the data when you logged in, right? And then throughout the session, the only requests that went out were just the requests where you changed the data. So basically, the data of the customer was living all in the RAM, right, in the browser. Still, today, we're working on it hard to get rid of it, but I'll get to that later. Yeah, so as you can see at the beginning, you know, picking minimal dependencies, using off-the-shelf solutions, nothing fancy. But of course, we scaled, right? So, you know, we had to think about this microservice architecture, and the first time we tried it was 2018. We tried to just like see how it works, right? We built one in Node.js, and yeah. Then again, we grew more, we learned some of the pitfalls of Node.js, and we decided that we want to switch to something more stable. So we picked the JVM ecosystem, right? Specifically Kotlin as the language. Yep. So maybe I'll zoom in a little bit on one of those lines from the previous graph. What I find interesting here is that basically half of the history of the company, we were running only on a handful of services. You will get the point later in the presentation why I think this is an interesting observation. At the beginning, also, I mapped here that we actually started using Heroku. So we were using a platform as a service. Because again, right, at the beginning, you don't want to be caring about if your server is up or down or whatever is happening. You just want to put your credit card there and just talk to customers, right? So that's what we did. But again, we scaled, we had more data, more customers, you know, we had bigger compliance needs. And so eventually we had to switch, and we picked Kubernetes for that. There's also going to be a slide about it. But what I want to emphasize is a lot of the times people mention price as the reasons for switching from PaaS or Heroku specifically to something else. Like in our case, it was not the main reason. It was more some of the visibility into the infrastructure of how Heroku works. Also gonna mention later in the presentation. Productboard went through a lot of migrations, and I would still say that we're still going through. So one of the ones I already mentioned, right? We started with Heroku Then later down the road, we decided that we're going to go with Kubernetes, right? And of course, we wanted to pick AWS. And also, the first choice for Kubernetes was not actually a managed Kubernetes. It was a self-managed solution. Because back in those times when we started, the EKS service on AWS was not, let's say, mature enough. It was some alpha, I think, so we didn't really want to bet on that. But I'm going to mention something about it later as well. Yeah, and on the front end, also a lot of changes, right? So, rewriting from JavaScript to flow type, which was cool at some time, right? And then again to TypeScript. Good learning, rewriting twice. And then also, I mentioned already, right? At the beginning, we picked a front-end heavy client architecture, and over time, we needed to stop downloading all the data to the browser. And that means that also you need to move the business logic. So there's a lot of movement of the code from front-end to back-end as well. Monolith to microservices. Again, you will understand why microservices is in quotes later in the presentation. Yeah, but you grow, you have more teams, you have to optimize for different things, and you're looking for some evolution of architecture. For us, it was basically moving from Rails, trying out Node.js, and then ending up with Kotlin. Yeah, and inevitably, you picked microservices, right? So you basically decided to solve all the nice problems of distributed computing, right? All the async communications, and you picked choreography, right? Because orchestration is too easy, right? Why not solve it the hard way? So there's already one learning. Migrations or adoptions of new technology is never a single point in time. It takes time. You should, when you try to do any of these migrations, you should always agree on certain deadline. You should limit the number of migrations that you do. It's especially confusing for new hires that just join your code base and they just don't know what's the latest of the latest of the latest thing, because there's just too many changes in flight, right? Yeah, and if you're in the last 20% of a migration, just split it into tickets, distribute, and get rid of it as quickly as possible, right? Don't let it linger. So let's get back to the topic I wanted to talk about, right? Technology. So you certainly don't want to be an ignorant, right? Like when you see a new cool tech, you don't want to be like, what is this? This is annoying. I don't want to use it. Another thing. What do we do? But you also don't want to be the guy who finds a cool thing every Friday and just pollutes the code base and the architecture with new things just because somebody said so on Twitter, right? Well, let me introduce you to Bill. This is Bill. Bill finds new cool tech. Bill thinks before adopting. Bill is smart. Be like Bill. So the question is how we can all be more like Bill, right? So I've taken a few slides from a very from a presentation that I like very much, and I refer to it very often, that introduces this concept of innovation tokens, right? Innovation tokens are just a form of currency, right? You have limited resources, so each token represents some resource, let's say number of engineers or whatever. But the point is that they are limited, right? And the concept that this presentation is trying to, the presentation I refer to, the Boring Technology Club, is trying to kind of introduce is that as a software engineer, you're trying to solve a set of problems, right? And when you solve a problem, you bring benefit to the company, you bring benefit to the customers, right? And you do that by using technology, right? But every new piece of tech comes with a cost, right? Cost of maintaining, cost of running, cost of, the drill. And so you don't want to end up with something like this, right? Like there's so many solutions, right, around. You want to end up somewhere more closer to this, right? So in a sense, you can say you can use less tokens to get the same amount of job done, right? So that's kind of the overarching principle of this presentation. Let's talk about something more specific. Who knows this picture? Who is still using this practice? Yeah, please don't do that. This is kind of an old practice that was introduced something like 10 years ago. You know, it was a different time. But like, you know, what is it really about? Like, what they're trying to achieve, right? Like, I would argue, like, you want to achieve continuous integration, right? You want to make sure that the code you're writing and the application that you're putting together works, right? It works all together, or the individual pieces fit together. This does not help you do that. Like, if you have like tens of different branches, you're gonna maintain each individually, right? It's gonna be a lot of overhead, right? Like, I would argue like that unless you are doing some software and you're still distributing on CD-ROMs, like, you definitely don't need this. Like, even the author put a note of reflection on his blog post that this is really not the way to go, right? And the recommended approach, of course, is just keep it simple, stupid, right? Just pick something much simpler, right? Such as this GitHub flow, for example, where you essentially have just one main line and you just create small, short-lived branches that get reviewed, right? As small as possible, because the longer they are, the more complex the review is, and the longer those branches linger, right? And you have the same problem as here, right? Question, on average, whose PR reviews take less than a day at their company? Interesting. So it was like 10% maybe, or something like that, maybe even less. Something to think about. Microservices. Well, everybody's doing it, so it must be great, right? So let's all do it, right? A lot of people do microservices, it's cool. Well, the reality might be that you don't need them at all. Actually, most people don't need them. One of the first things that, like one of the first chapters for microservice books usually is this nice chapter, which in my mind looks like everybody skips, but it's the most important chapter of them all. It's don't build distributed systems. You don't want to do that. Somehow people just skim over it and they just go into details of how to actually do it and they don't listen too much. So please read that chapter. Yeah, but like even when you actually decide to go with microservices, right, or you want to get closer to it, and you already, for example, have a working application, right, you don't have to go all in at once, right? So I picked this nice picture from Martin Fowler from one of his articles, where he describes how you can gradually move out from a monolithic architecture to a more distributed one. You don't have to start deploying everything separately right from the beginning, right? So specifically on this example, let's say that you're building a e-shop, like a typical e-shop, right? Where you have a cart functionality and checkout functionality. And for some reason, you decide that it might be a good idea to separate those, right? But you don't have to create two brand new services right from the get-go, right? You can start simply just by separating the code base into one service, right? Making sure that the code is not interlinked, right? There's no imports and requires in between, right? You just make a sensible structure in the code, right? And only then, when you actually see a very good, compelling, specific reason of why do you need to deploy a specific module outside of that, you can start deploying it separately. But even then, I would argue that you have a lot of tools in your tool belt for inside the monolithic architecture where you can actually deploy, different deploy artifacts from an actual monolithic architecture, right? So you don't have to go all the way. My favorite topic. So microservices, right? So the question is, how micro is micro? Like, who knows? Like, what's the right size? Well, that's the point, right? It depends, right? But like we can say, I think one thing, like the more you cut, the more overhead you're gonna see, right? So you should be very mindful about how you cut and how many services you actually introduce. There's a lot of these like opinions that maybe you should write the service in a day, right? Or changes should be collocated. It should be easier to onboard yourself as a new hire because you see only one service. There's so many of these like opinions. I think if we were to follow that at Productboard, we would probably have like 10,000 microservices. Like that's like no, please no. Think before you cut. Kubernetes. So you already decided to go with microservices, right? And well, you have to run them somewhere, right? So yeah, well, the latest thing you can do is, of course, Kubernetes, right? It's amazing. It's a great piece of tech, of course. Helps to simplify running workloads. In a way, it's basically a glorified distributed manifest, right? But sadly, that's not how most people use it, because when you start with Kubernetes, you don't start with just Kubernetes. So first, well, we have to keep the specification for Kubernetes somewhere, right? So let's do Terraform, of course, right? And then we have to deploy those things in the Kubernetes, right? And we don't know write those pesky, deployment files. So let's pick a templating engine, it's Helm, right? And then, well, the rollouts in Kubernetes are not that advanced as we want them, well, so let's pick Argo CD. And because Nginx is boring, we have to pick something else as a web server, so let's do traffic, right? And because what is not monitored does not exist, so you have to deploy your own monitoring solution, Grafana and Prometheus, right? We, in the end, eventually ended up kind of moving over the monitoring part to Datadog, which, again, right, you're kind of balancing cost and, kind of usability here. If it were up to me, I would stick with Heroku as long as possible. Like, somebody would have to, probably put a gun to my head back in those days to really kind of make me do it. Because the simple fact of a platform such as Heroku is that you just go there, you put your credit card there, and infrastructure is solved. You want more capacity, you click a button, right? Amazing, right? Like compare that to running, your own pieces of infrastructure. You need a team for that, a lot of knowledge, right? And it keeps changing. You have to upgrade everything. You get the point. Well, not everything is shiny, right? With PaaS, specifically Heroku. You probably don't see all the labels here. So on the horizontal axis, there's time. And on the vertical axis, there's max response time of our web servers, right? And you see 6 web servers here, right? So this is a log of an incident that I was working on some years back on the Heroku platform, right? And you can notice a very interesting thing. Heroku has something that they call a distributed router. It's amazing. It's so distributed and so random that when one of your servers gets completely overloaded, it does not even level out on the other nodes, right? So essentially, a single node is a only bottleneck of the whole architecture, right? Of the whole infrastructure, right? So I got like very mad, and like I had this like statistical spreadsheet of like, does it make sense to have one big one or like 6 smaller ones? And like, yeah, so yeah, that's one of the reasons why I also actually wanted to switch, but I think I should have bitten the bullet and stayed with Heroku for a bit more. Domain-driven design. I also spent a few years on this. The first realization should be that domain-driven design is not just about code. Actually, it's not about code. It's actually about the business. It's about how you organize. It's about how you communicate. It's about the strategy. And then maybe it's about the code and how it should relate to each other. When you start reading books, about domain-driven design and blog posts, you will encounter terms like, bounding context and anti-corruption layers, right? And then a lot of people mix it together with like, event sourcing and CQRS and like, you have to have end-to-end ownership and everything is awesome, right? And then you try to implement it all and it's like not possible, right? Well, it's not possible also because even the companies who advertise something don't use it themselves. Interesting, right? So that, nice Spotify article where they introduced the idea of end-to-end ownership, right? And like we should have everybody together, and like they need to have a single service, right? It's all one-to-one, it's easy and everything works. Well, not really, right? There's a great article online, actually from somebody from Spotify, where they describe what actually didn't work, right? How they had to adjust. So I think that those articles are a great inspiration. You should always take it as an inspiration. You should never copy it one-to-one. The other reason why you might misinterpret some of these articles is because simply you're not building their product. You don't have the same team they do. You have a completely different tech stack. So there's so many different variables that when you're reading that article, you don't understand, right? And so you might have a chapter about the teams, right? And how they have end-to-end ownership, but nobody tells you that team in their company means 100 people, right? So now you kind of invalidated the whole point of having end-to-end ownership. And when you try to implement end-to-end ownership on the level of a squad, well, you will have different problems, right? Monorepos. So you have too many services, right? So have too many repos. So now maybe you have to somehow put it together, right? Because it's just Google. Google is using monorepos. Let's do that. Well, again, right? You're not Google, right? So maybe not looking at it like ad absurdum. You don't have to always like copy it one-to-one, right? When we think about monorepos, for example, as I showed on some of the previous stats, we have a monorepo, but we don't have a monorepo for everything, right? So in our case, we're using monorepo for the front-end part of the architecture, but we have also more repos around for various other stuff, right? Dependencies. Dependencies in the wide sense, right? Dependencies in the sense of packages, the cloud you're using, third-party services that you're using, right? There's an interesting thing happening. Like depending on which article you read first, you are more likely to do that mistake. So there are articles about like vendor lock-in, like you should not vendor lock-in yourself. Like if you're using AWS and you're worried about lock-in, like if AWS goes down, like you have different problems, nothing works. So like use the platform, use AWS. But on the other side, you have articles like claiming, well, you know, we should like use other people's software. It's amazing, you know, let's just use all the packages we can find. Well, there's also an extreme, right? You don't want to end up in a situation where you're basically depending on a library that's doing a simple function, but everything breaks, right? So that's kind of my rule of thumb. Like, you know, when you're looking at that library specifically, just analyze which piece of it are you actually using, right? And like, is it one function? Is it the whole library? You know, and depending on that, you can make the right choice if you're gonna adopt it at all, or if you're just gonna write your own piece of code. I have this weird custom that I usually prepare myself for presentations when I'm traveling somewhere, like in a train or in a plane. But the problem today is that I live in Prague, and so the drive was not that long. But anyway, I tried to summarize some of the more learnings I wanted to give you in this slide. First of them being UIDs. Who in here is still using sequential IDs for primary keys? Okay, so that's a little interesting. Good. This is actually the exact opposite of when I was presenting it like a few weeks ago, which that's good though. Use UIDs. It's amazing. It solves so many problems. If we were to know this a few years ago, it solves so many problems. It solves migrations. It solves like geolocations of your infrastructure. It solves optimistic updates. It solves so many different things. You're gonna thank me. Start with UIDs. You very likely don't need Kafka. Who's using Kafka? Okay. There are so many alternatives. There's native alternatives from AWS that you can just take and use. You don't have to, learn all these new concepts from Kafka, right? Kafka has its uses, it's an awesome tag, right? But again, I think it's overused a lot, in my opinion. Modularize your code and avoid cyclic dependencies. If you're considering microservices, think about your monolith first, right? If there's one thing that you can start doing from the beginning, even with a slight overhead, but I think it's still gonna have return or value, it's that you should modularize your code, right? Like just pick whatever is the construct in your language that has modules, be it directories, be it namespaces or whatever, and just put your code into buckets, right? And then compose those buckets into an overarching application, right? And that's the important piece. Do not interlink those buckets with each other. Because if you do that, then you're gonna end up in a situation where you have cyclic dependencies, right? Why is that such a problem? Well, it's a pain in the ass to get rid of it. For us, it's already taking a few years, and I think it's still gonna take at least one more. Well, what do you think? Yeah, so just don't do it. Deprecating monolith will take you years and maybe multiple tries. I think we have like a third try right now of deprecating the monolith. Deprecating the monolith should not be the target. Deprecating the monolith should be the way, right? So, you will make many mistakes. Maybe you will pick Kubernetes and everything else with it. Maybe you will go with CQRS right from the get-go. Maybe you will go with choreography because orchestration is boring. Just go simple. If there's one single thing that you should take from this presentation, it's KISS. Keep it simple, stupid. It's the, I think, most underappreciated principles of them all. The more you can do with less work, the better, right? That's the key. In the case of Productboard, we've built a lot of the functionality on a few foundational classes and functions. So the front end essentially was built on top of 3 classes and 2 higher order functions, right? They have in the order of magnitude of like hundreds of uses, maybe thousands, but they are the backbone of the whole application, right? So if you want to make some more foundational change, you can do that very easily just by changing those very few pieces. It's also not that challenging to learn for new people, right? Like, because you've composed the whole thing just by using a few simple principles. And on the back end, it's a pretty much standard boring MVC app, right? So a lot of models, a lot of controllers, a lot of views, and some jobs maybe in the background. Again, hundreds of uses. That's where the crux of the application lies. If you are interested in how I actually generated those stats at the beginning of this presentation, I just open sourced a little bit of it. I spent like 10 minutes with ChatGPT. It's nothing like too complex. Just don't get like, hung on like details and everything. It's pretty ugly. But I think you can get some inspiration into how to actually analyze some stats. I think you might find it helpful. Yeah, that's it for me. Okay, thank you for the questions. So let me read the first one. How do you manage code-free situations, preventing newly developed features interfering with stable build with a simple feature bench in GitHub Flow? So there's this concept called feature flags, or people call it different ways. We call it feature flags, where you basically just if or condition out the piece of the code that you're merging into production, right? So I'll ask after I finish. So basically, you just have, so for us, we're using LargeDarkly. So we've already kind of outsourced this work because we don't want to manage it ourselves. you know, it kind of gets complex over time. Like the more of these features that are not developed yet you have on the main line, the more complex it gets. But it's still significantly less complex than rebasing, you know, 20 branches. So that's what we use. I think there was a question maybe connected with it.
Do you have some questions? I can. Yeah, can you please repeat it so everyone on the stream can hear it?
Hi. You asked question why you can use feature flag. No. Because on the first question. So because some reason you not allowed by legal to deploy something that is not was dedicated yet to be.
I cannot argue with lawyers, so.
Yeah, that's the
Sorry.
point. That you cannot use feature flag in that point.
Might be in your situation. I think there's like we obviously have to be compliant as well, right? So I guess it depends on your model of compliance. I guess talk to your compliance officer like about how to actually structure this. Maybe you're doing medical or something. Maybe you're in a field where this is very, very fragile. So maybe you're really constrained. As I said, there's definitely businesses where it probably makes sense, but for the majority of, let's call it SaaS, you know, like applications for online use, I think you're targeting CI. I don't want to make it over complex. Is that sufficient answer? We can talk after. Can you summarize pros and cons of using UIDs versus sequential IDs? Are benefits of UID the same for non-sequential IDs, e.g. CUID? So I didn't want to specifically pick UIDs as the only way how to identify like uniquely, right? What I was specifically saying is that avoiding sequential IDs is a good thing in the sense that you can distribute the algorithm much more easily. So what I mean by that is you can have multiple databases or applications or entry points into your logic where you can actually create the ID. And that's super, super helpful when you actually want to create some more complex data structure, right? Because like if you cannot represent things by IDs, you cannot connect them, and then you cannot create a complex structure, right? Or it's at least much harder to do so, right? So that's why I think that the biggest benefit of not using sequential IDs, there's obviously also a good thing about it, right? You can use those sequential IDs in URLs, right, to make them nice. You can introduce, you know, tags in your application to like uniquely identify by numbers, which is much easier to understand and, you know, send links for users. So yeah, that in my mind are the comparisons between UID and sequential ID. How do you manage? Well, I think I answered that one already. So why did you leave Node.js? I'll just go with that one. I have to be honest. I simply cannot imagine how somebody can build a production-grade, large-scale enterprise application in Node.js. Like, don't get me wrong. I think it has some very, very like relevant uses. For example, when you're doing some worker-based architecture, you know, when it's just a piece of work that you need to do and then you finish. Maybe I think that for that it's great. Or if you're building a fast prototype, right? Next, and all those awesome technologies are for the grabs. But as I said, I really don't see how it can be scalable and reliable. It's the second one. How do you decide whether to start development of a new service in a monorepo versus standalone repository? What problems have you encountered with monorepo? Least amount of work with the most amount of benefits, right? So I actually don't know what's the intention behind this question, but there's probably a reason why you start a new development of a feature, right? What is that feature? What is it doing? Does it mean that you need a new service? Does it mean that it's a new module? Like, I don't know, it depends, right? In terms of the problems with monorepos, of course, they have attacks, right? So because if you keep a lot of things in one pile, you have to somehow structure the pile, of course, right? So I would say that tooling is pretty important. Like somehow leaving it up to the computer to basically help you to not break the rules of modules, basically, right? Because if you have separate repositories, like you probably won't do that many mistakes. But at the same time, even the repository won't help you from runtime coupling, right? There's two types of coupling. There's coupling in the code that you see statically, and then there's runtime coupling, which means which service calls which in order for something to be done, right? And many repos or microservices actually don't help with that neither. So there's trade-offs. It depends. Can you compare the first? Can you compare the time it took from 0 to releasing a feature in the first year of existence of the code base and now? It was so quick. It's extremely quick. It was at the speed of thought and my fingers. That's not the case today, of course. We have hundreds of people on board. We have plans. We have to synchronize. There's dependencies. We have to plan, right? We have to always think about adding new piece of functionality if it actually fits in the overall product, right? So there's a lot to think about. It's much easier to start with a greenfield, like, you just keep adding stuff and adding stuff. But I would say eventually you always end up in a situation where it's just slower. But slower is not always worse, right? Like as long as you deliver customer for your values for your customers, then there's no problem. Why did you choose Kotlin and not Java? I think it might be also a case of coolness a little bit, but at the same time, yeah, it was just too talkative, right? Writing Java is kind of like, like you have to type a lot. Yeah, at the same time, to be honest, I think we're looking at the market. So the reasons were never technical, right? We never switched stacks for technical reasons. We always switched for personal hiring reasons, right? So in the case of Rails, the market just got too small, right? It started to get very challenging to hire new folks. So we had to pick the ecosystem where we think there's some bigger future, and Java is ridiculously huge. But at the same time, there's a lot of people in the Java ecosystem you frankly do not want. And so in my mind, it might be a good idea to actually differentiate yourself somehow. Some of the folks who were using Java, let's say for 10 years, maybe they're already fed up with it. They want to try something new, but they don't want to switch completely to some completely different ecosystem, right? So they just pick a different language and they still stick with JVM. So I think these are the types of folks we are actually interested in right now. A lot of experience and want to try Kotlin. That's, I think, the best fit for us. Yeah, I think yep. What makes Node.js not scalable? Yeah, I think we're getting to a more of an opinion land at this point. I certainly don't want to look like a god, like having answers to everything. So if you have more questions like this, just catch me at, the beer or the pizza that's gonna come, I hope. And let's talk. Thank you.
Maybe, do we have any questions from the audience? Yeah, sure.
You mentioned CQRS as one of the buzzwords. Do you have any experience with it on Productboard, and was it used for the right use case? Or are you happy with it, or can you describe it briefly how you used it?
It's like, I think at the beginning it's important to ask, what do you think CQRS is?
Command query request separation? No, something like that?
Again, please?
Command query request separation.
Yeah, again, what does it mean, right?
What does it mean? Yeah. I think it means like having asynchronous requests for the mutation and not getting like the results exactly, and separating querying of the data in a separate context. This is how I understand it, but I'm not an expert. That's why I'm asking,
Well, the point is nobody's expert on this, right? But like by the definition you said, we were doing CQRS since the day one, right? But it's probably not what you're asking about, right? Like I think in our in our architecture, we started looking at it more recently when we started using multiple databases. And when we started, one of the drivers to use multiple databases was microservices, of course, because, if microservice needs to own data, again, another good practice, right? Then you need a database, and you have too many databases, and then you have to sync the data. And now if you sync the data, where do you write the data? And then where do you read it from? And all these things. So like, in a way, we tried it, but I don't think we really succeeded in the sort of like, let's call it like Netflix-like, fashion.
Thank you.